we're talking about fundamental types this week. We have discussed numbers. There are other uh, fundamental types, such as characters, and there's also Boolean. Boolean is simple, but we're going to talk more about Booleans later on when we talk about some of the operators. Um, but right now, let's start with character types. So, of course, we need to be able to um, deal with characters, and there are many different types of characters because the complexity of encoding characters uh, in natural languages, in the just symbols that we use in our language systems. And so here's a couple of examples. You probably have seen char, which is the a single which it holds a single character, usually in the ASCII encoding scheme, and it cannot hold sort of the characters that are in a larger character set, and so this is somewhat limited. And char is different from signed char and unsigned char. Now, is char signed or unsigned? This is actually implementation specific. It's defined by the compilers. So you may get a different situation, but normally, do you care? You shouldn't. But then you also need to be aware that char is actually a integral type. This can hold integers as long as you don't go beyond the range. That you can still use a char in a arithmetic operation, plus, say, for example, this uh, letter A. If you use this variable +1, and you advance to B, because the code point in ASCII advanced by one position, that happens to be the capital B right after. Then we also have the other types that deal with a specific character encoding, and this W char is also called white char. And by the way, there's a naming convention with _T representing type, and you see actually a lot of types in the standard library ending with _T. So this W char, if you want to use a character literal that initialize a variable like that, you need to prefix with a capital L in front of it, just like what I shown here. And this letter can be represented, held in a W char variable. Now, W char may be 2 byte or 4 bytes, and now char is typically 1 byte. So this W char is notably used in the Windows API a lot, and not as much in the other systems. Then you've got the char 8. Now, this char 8 represents a code unit in UTF-8. Now, UTF-8 is a Unicode standard. Now, Unicode standard this corresponds to the Unicode standards. You have UTF-8, UTF-16, and UTF-32. Now, in the UTF-32, each code point is represented with 32 bits, and so this a single type here can hold a single code point. And then in UTF-16, each character may be represented as a 16-bit or 32-bit bits. And so this, to represent the whole range of UTF-16, you may use one or two of these. Now, in the UTF-8, which is another variable Unicode standard, you have 1 to 4 bytes to encode a character depending on where the code point is in the character set. So so the obviously the smallest unit of a code point is a single byte, and so this char8 is for that purpose, dedicated for UDF8. So that those are the character types, fundamental types. Now, of course, a single character doesn't do much. So we'll learn how to have sort of a sequence of characters. That's more of, you're going to see a lot when you deal with text, obviously. And that is the topic of another week. So we have seen use the IO stream processing to output text into the console. And we haven't really talked too much about formatting of the data, just kind of, print out the variables as is. Now, if you're printing out numbers, sometimes you want to, for example, for floating point, you want to specify the precision of the fractional portion, right, of the numbers. And then you should be able to manipulate that. And so with IO stream, you can. There's actually a ton of um, sort of functions, objects that are actually specified in the library that allows you to modify how you want to format your data when you deal with IO streams, input or output streams. And what I listed here in this table is just a couple of fairly common ones that you may use if you're dealing with IO stream manipulation. And this subject here is actually a link that goes to a reference page that actually has the full list of it if you're interested in that. As an example here, so there's a bool alpha. Now, the bool alpha means that if you have a Boolean variable you want to output, and then this will, if you set this, and then you will output, if it's a true value, and then you will just output the word true in alphabetic letters, and instead of 0 or 1, right? And then the no bool alpha is the opposite; it disables that. And there's also a couple of manipulators dedicated for floating point, fixed. For example, that's a fixed point representation. What that means is if you, let's say, you have a pi, right? 3.1415 something. If you set a fixed representation when you output, then it combines with the precision. When you talk about precision, that's the how many number of digits after the decimal point. If your precision is 2 in the fixed mode, and then the output would be 3.14. If you're not using the fixed mode, then the output, like, basically is the opposite, is the floating point, right? The floating point, in that case, if your precision is still 2, then the output will be 3.1. So 2 significant digits. That's the precision. And there's also different format for floating point numbers, scientific notation that you're aware of. With a e in the middle that represents the exponent, and then after the e you have the number that represents the exponent. Before e is the mantissa, or the significand. And then there's also hex representation of floating point numbers that essentially instead of using the decimal numbers, it's going to be represented in hexadecimal notation for the significant portion, mainly for significant portion, will be represented with that. And then set fill, this is for sort of a tabular data. When you print out to the console, you want to somehow present that in a tabular format. And then you may use this set of fill to say, I want to use, space, or maybe use asterisk as the fill character when you align the data in the cell of your table. Precision, that's actually the one that's to set the floating point precision. And then you have also set W, which is the width of the next field. So this goes with the fill. Fill is what character you're going to use if it doesn't occupy the whole width. And this is saying how wide that field is. Now, let's take a look at an example, though. Here's an example of a set precision. For example, this is so we're trying to print out. Okay, first of all, we have a long double pi, which is mathematically is the arc cosine of -1, right? So this is basically what we're saying. We're gonna just um, get the pi value this way. And by the way, you can get the pi value from numerical limits. I believe is in the numerical limits. It's part of the standard library. But anyway, just for a little bit of fun. And then we're going to print out the value of a pi in different ways. And now there's this default printout. Let's actually run this now. So basically, this is in the playground. And we're going to just build it. Okay, and then we'll run this. So now you see the output actually. So you see by default, the default precision is actually 6 significant digits. The precision is 6. And in the floating format, meaning the dot is floating, and so you're counting all the digits without a dot. And then if you then you can modify the precision, say I don't want a 6, I want a 10 of those significant digits, and this is what you do with this set precision that I put in the table. Again, it's in the standard namespace, no surprise here. Not everything is in the STD namespace because there's some things that are actually in the sub namespace, but still starts with STD though from the standard library. So you basically you make a change of the precision, and then you print out your variable. Okay, and then this here is another set precision, and so here we just say we're going to set to 10. Well, we actually don't know if that is the maximum that you're allowed to set in dealing with this compiler. So the thing is with a long double, we don't know what the maximum precision is. And now actually there is a way to do that. Remember that we say to query the numerical limits, and this is where you go to. You go to the numerical limits library, and then this is the class you can use to query. And this digits 10 essentially querying what's the maximum number of decimal digits that you can use for the significant in a floating point in a long double here. So we're saying for this particular type. So this is actually going to give you, if I hover over this, actually the IDE shows me what the value is. The value is 18, right? As you see over there in the pop-up. And so in fact, this precision would have been set to 19. If you actually count the digits, it would be 19 digits, okay? So the next thing I want to talk about is the alternative formatting mechanism, and this is the new feature in C++ 20. Well, in fact, what I think is this formatting library has come too late to C++. I mean, seriously, this is has been a little bit pain point. And now, okay, so like this particular way of formatting output, it's fine, it works, right? But it's fairly verbose. You have to write a lot of stuff in terms of it's just not very compact. For those of that who have know Python, you know the string interpolation. It's fairly sophisticated, and then you can actually have uh, sort of like a string template, and then you can interpolate the placeholders with. And this is not just the Python. And most modern languages they have that fairly decent text formatting facilities. And C++ has been lacking. Well, there is a printf, right? If you are familiar with a C, that is still somewhat primitive. It's now finally C++ has caught up. So let's take a look at this. In fact, the format is very much borrowed from Python for the most part. So this is a function in the format module of the standard library, and so you would have a pattern string, and this pattern string here, this is just more natural. So you have a text, and then in the text you have sort of variables, right? So this, for example, this is the example from the book. Pond diameter required for something fish is something feet. And then you have two variables that supply the value that gets placed into those placeholders with the braces here, a pair of braces. And so this is going to match with the first argument here, and then the second one will match the second argument, and so on. So there's something here that seems a little strange with a colon and something dot two. Now that's a format specifier, and that's actually the mechanism to format the value that's put in will be output. Now the return value of this function is actually the return is a type of string. It's a standard string. Excuse me, standard string type from the standard library. And we'll talk more about the string type a little bit later. Now, that string is a standard class. It's not a fundamental type. So here we're going to be focusing on fundamental type. So the format of the format we can put into the placeholders in this pattern here has a specific format. Looks a little long, but it's not that complicated. In general, you have this many components. Now the square bracket means that portion is optional. Well, as you see, they're all optional, right? So as now, for example, this right here, you're not using anything. That's totally fine. So you just get in the default behavior. Then if you do want to format your values, and then let's say in a tabular format, you want to print something, sort of with alignment into sort of cells of a table, and you can do that. So the portions of that specifier that will be used for tabular data is this couple of things. So the fill, again, that's the fill character, is very much the same as what we saw in the IO manipulators, like set fill. This is a fill character in terms of alignment. When you have, if the value doesn't occupy the whole width of that field, and then what is the character you want to use to fill? By default, it would be just space to fill, but of course you can choose to use whatever. And then align is you want to align to the left of that field, to the right of the field, or to the center of the field. And then so you can use the left length character, right length character, or the hat character. And that's the alignment. By default, it aligns to, well, by default, if it's numbers, is right aligned. If it's text, it's a string, it's left aligned. That's the default behavior. And then you have a zero here. Zero here, this is for integral, well, for numbers, actually. For numbers, and then you can use a zero to fill. Now, not this obviously is not meant for string or characters. So this is zero here. This is you can optionally specify you want to use it. You want a zero fill the number when you align the number in a field for tabular formatting. And then you may also have a width that, of course, how wide is that field when we talk about alignment and fill. So this all goes together. And then the format for formatting numbers. So there's the portions, right? So kind of just divide that whole general format into two parts. And then the other part was left is you got the sign. So this could be a plus, minus, or a space. So if it's a plus, means if you got a positive number, now the default behavior is not going to add a plus sign in front of it. But if you want to, then you can specify the plus in this position. By the way, this is a whole string. There's a relative position. You have to put them that way if you actually specify them. No, they're all optional, but if you do provide them, they have to be in this relative order. Okay, that's what this is. So it could be a plus sign. Now, if you put a minus sign, that means, well, the negative number will have a minus sign. This is going to be always the case. So this negative, if you do a negative sign here, a minus, this is actually the default behavior. You don't have to use it. And then you may also use a space here. If you do the space, that means we would just leave a space in front of this positive number. And then this hash symbol here, hash symbol turns on the alternate formatting for numbers. For example, for a binary number, it will add a prefix 0b. For hex number, hexadecimal, then you will add a 0x in the beginning, a prefix, right? Just like the literal numbers. And that's basically what it does. Then you have the precision that we actually talk about in the out manipulation. This is where you specify the precision, and this is actually what you see right here in the example, dot 2, right? So you do dot 2, 2 is the precision that we want. Now, from the previous discussion, we know the precision could mean different things. Are we talking about floating type of number or fixed type when it's formatting the floating point numbers? And so that depends on the type indicator. So if your type is F, that represents fixed, and then you have a number 2 here for precision, and that means that you're going to have 2 digits after the decimal point. And if you don't have that F here, so by default it's going to be a floating type, and then this is the total number of significant digits. In terms of in the example of a pi, it would be 3.1. Of course, there's other types of numbers, right? You can use a B representing binary. You can use, well, for the hexadecimal number, you can use either X for integral numbers, integers, or A for floating point So there's a hex representation of floating point numbers. And then you may have octal numbers. The octal, you just use is O here to represent it. And then some of those numbers can be capitalized. If it's a capital B, and that means the prefix of the binary number. If that is turned on in the alternate format with a hash symbol, then that 0B would be a capital B. So just this minor variation there. That's for the most part what this is about. Now, if you want to know the full spec, by the way, this is actually missing one more thing, which we don't really talk about here, but that is not used very often. So if you do want to see everything, what's possible, here's a link that goes to the website, and it has everything that I just talked about. There's a lot more. Now back to that example here. So I've added actually a formatting with this format function. So you see the output of that is the same, right? You see the set precision IO manipulation method, and then there's this standard format function method, and then this is the format specifier that I used. I will have a space here. Remember this space. You can basically, that is like the position for the sign. I just kind of use this to line up the number. That's what I did. Okay, not a big deal. So dot 10, that 10 is the precision. And of course, we're taking the default behavior, which is not fixed, not the fixed representation when you print out the floating point. So that's really what that is. That's equivalent to that. And if you look at this format function, it just looks more intuitive. You're not breaking up the string you're trying to print out because you have variables embedded in a whole sentence. That's typically the case. So it's just, I would say this is a better way to format a string. So that's kind of also the approach that the book has taken, and going forward is going to be using this sort of format function extensively for the examples. I like to go over the summary of the chapter. There's some good pieces of information, just help you go through those. Again, these are the chapters. There are fundamental, still pretty much basic of C++. Hopefully you don't have too much trouble understanding most of them. If you do, please ask in the discussion board. And yeah, so let's take a look at this. Okay, so what was discussed in this chapter? So constants of any kind are called literals. So when you initialize a variable with a value, that value, let's say, is a number, is a some kind of string, and those things are all called literals, and all literals have a type. So the compiler will give it a type. Now, depends on how you write the literal, and then the type will be determined according to that rule. Now, the integer literals can be represented as decimal, hexadecimal, octal, or binary values. So there's a prefix you can use to designate what that literal is going to be, right? 0x, you have 0. The octal starts with a 0, which is a little funny, but this is how it is. And so it doesn't really get used very often, but again, you might use it occasionally, but you need to be able to recognize it. And a binary is 0b as the prefix for literals. Floating point literal must contain a decimal point or an exponent, or both. So that That is just a requirement for the compiler to recognize what you're trying to convey. Or you're writing an integer or you're writing a floating point, right? So you must have one of those. The fundamental types that store integers are short, int, long, and the long. And actually, you can also use a char, although that's usually for characters, but chars can also store integers. Now, these, when you write the type names like these, they are actually all signed. You may have used unsigned version of them. Just add unsigned prefix to those types. Floating point data types, you got float, double, and long double. Now, as I said, the double and long double, well, the long double has to be at least as big as double in terms of the size, but then the standard doesn't say how much bigger, right? So they could be equal. In fact, some compilers will make that equal, but then some compilers will make them a little bigger. But then even in the same number of bytes they represent, and then they may have a different precision. Uninitialized variables generally contain garbage values. So if you declare a variable, it generally is a good idea to initialize it right away, even if it's just zero. If you just initialize it with a zero, just use empty braces. The brace initializer is preferred. It doesn't have the side effect of a narrowing conversion, for example. So you may want to start getting used to that. In the old days or in C programming, you probably see a lot of this assignment as initialization. Well, in C++, that works the same way. It can be equivalent, but then there's just a few minor cases where the braced initializer is it's superior because it doesn't give you unexpected results. A char, those are char types, character types. A char can store a single character and occupies 1 byte. Whether it's assigned or unsigned is implementation defined. And so you may have also char, assigned char, unsigned char, and those are actually different types. And then we also got wide char, the wide characters. Essentially, the char comparing with this would be called a narrow char. But anyway, this wide char stores a wide character. It may occupy 2 or 4 bytes. And the types of the char 8, char 16, char 32, those actually are better for handling Unicode characters that's designed for that purpose. And the value of a variable can be fixed with a const modifier. And you're going to see const quite a bit. And there is a reason why. Actually, generally, the recommendation is use const as much as you can. But you don't want to go overboard. But because that gives you, it makes your attention clear, and it just prevents a whole class of bugs in your program. And then the arithmetic operators, we have, talk about the addition, subtraction, multiplication, division, and also modulo. And the increment and decrement operators, they're essentially just shorthand for adding or subtracting 1 from the numerical value. And they can be a prefix form and a postfix form. Remember that in a prefix form, the value of the variable is incremented or decremented first before it participates in the evaluation of the expression. And the postfix is the opposite. And the original value of the variable will be used to evaluate the expression first, And then after that is done, the value of the variable will be changed by, adding one or subtracting one. So it's like you getting a second statement uh, by writing that in a compact manner. Sometimes though, you know, general ideas don't try to squeeze too many things into one line. It's not about having the shortest number of lines in a program, and it's actually more important to make your intentions clear. And clarity is important when you, especially when you work with a team environment. You don't want to introduce on bugs just because your code is somehow difficult to understand. And if you have different types of variables and constants, right, in the expression, if you have, a plus b, if there are different types, then the compiler is going to try to do an implicit conversion to essentially upgrade the lower range uh, variables or constants into the higher ordered types, and then it will perform the operation within the same type. So in the simple cases, it is fine, but I think generally speaking, again, make your intentions clear. You may want to consider use explicit conversion with static cast operator. Okay. And then the standard format function, it has many options to format text, and that's sort of preferred to the earlier style of I/O manipulators. It's just more compact, more intuitive, and you probably have gotten used to things like that in many other languages. So that's it for this chapter. Thank you.